This is the engineer, and a good morning to you. I've got one of my rules here in effect. Use what you got. I got a blank piece of paper and some pencil lead, and going to animate with it. And there's going to be an issue with, focus and whatnot here. Please bear with me. At this angle, if we focus on this little point nearest to us, we get this effect, this horizon effect, where things are getting closer the further away they go. And I'm relating this to, as we look off into the distance in space. But when we look into space, we look further back in time. So it's not just that they are looking closer together, they in effect are closer together. And what I want to talk about is the acceleration that is perceived from the observation of our expanding universe. Currently, though, I just disagree with some of the theories. Now, if we zoom back, and I focus this while it's, there we go. If we zoom back and think about the early universe being congealed and close together, and nothing's been made up yet into atoms. It's all subatomic particles, and quite possibly go further back if we accept the idea of string theory. And I'm not saying I do, and I'm not saying I don't, but it's a theory, so it's got to use little quoting marks. And all of a sudden it goes pop, and we start seeing an expansion. So as we zoom in, what we're looking at is the dots getting further away from each other. And so as we zoom in, we have a great distance that forms between each of the dots. If we were to do this at an angle, when we get closer and closer, the dots in the background remain closer together. They still expand, but at a slower rate, and the dots that are closer to us expand at a quicker rate. All of the dots are expanding at the same speed. Now, for this one, when we do move in closer, we have to take it from two perspectives. The area around us, let's see if I can get this focus again. I know, that's a poor representation of what I'm trying to say. And that's a great representation of what it's just poorly executed. It doesn't have all the flash and pop and bang of some of the animations that are currently out there. But I'm okay with that, because I'm going to get my point across, even if this won't focus. Oh, that's nice. Now, looking further into space and backwards into time, we can make the assumption that they're expanding at the same rate as we are now, but we can't see that because of the time that it takes for light to get to us. And they're talking about the distance that things are being going faster away from us than things that are closer to us. Now, what I want to talk about is that in this expansion, as we see the points moving further and further away from each other, they're all moving uniformly away from each other. And this is important because this is what's occurring, or at least this is what I believe is occurring, and I think is maybe being overlooked by popular physics. Because at your angle of expansion, if we were to view, come on, hold on, there we go. We're viewing the expansion occurring around us. and that away from us. Now these particles, or I'm sorry, these points, matter, galaxies, super galaxy clusters, things like that. As lost balance here. I don't know that that's accurate. The most accurate one is this one up here, straightforward and down. It doesn't appear this way when we look out from our point. Maybe it's backing up that we need to do. No, that's not going to work either. And my point is, I've been reviewing explosions in high speed definition, slow motion. All of the points expanding away from each other are moving away from each other at the same speed. But if we're to couple the the expansion away from this point and this point, they'll move at the same speed. But so is this one moving on this. We have to add the expansion or the movement away from this one that is moving from this one to the perspective and the observation that we see here. If we were to move along any given point, any given line, away from us, we'll see that as we look further, they seem to be accelerating faster and faster away from us. And this is true in observation, because from, let's go deeper in here. This one here is moving equally distant away from this one, and 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 this one, at the same time. They're all moving away from each other, but it's true for every single one of them. And because of that, the further you go out, the faster they're moving away. Because this one is not only moving away from this one, but it's moving away from this one, which is moving at the same rate away from that one. So, and it looks like it's moving faster. From our point, everything's moving away from us. But if we're looking at it like this, it's all moving at the same rate. And it's an optical illusion. It is an optical illusion that things are accelerating the further we go out. Because they're not accelerating away from each other. The acceleration comes from coupling the movement away from any given point. And that we see into the past, the further we look out, it's something that's already happened. So even though they're all moving away from each other, it's already happened. And what we can view closer to us, and relating the speed at which these galaxies are moving away from us now, and monitoring that expansion, we'll have a better idea of what is occurring elsewhere. Because it's uniform throughout an infinite universe. We don't have, if we disband the notion of there being any limit to our universe beyond our cosmic horizon, because when you view explosions, either surface explosions or aerial explosions, underwater explosions, they all have additional factors of gravity. The explosion itself is centralized, and the energy from that is also, well, and I guess, I'm stumbling through this. I didn't rehearse. I'm not going to rehearse. That's ridiculous. But I'm making my point anyway. If the energy of each of them is the center pushing away from the points nearest to it, and all of them have that energy, all of them have that force, it spreads them out relative to their nearest point. Like smoke. When you see smoke billowing and expanding into the air, it looks pretty uniform. Everything in the smoke has energy and is bouncing around and mixing with the surrounding. And if you were to choose a single point from there, it looks like the further away you go, it would be accelerating faster and faster and faster the further you got from your observation point. Or so that's the theory. This is what I believe. And I think it can be proven. I just don't know how to do that. I see it quite clearly in my mind. And I'm sure that there's a math for it. I just don't know the math. But that's why I've been looking for help and scouring videos, because it seems too obvious a thing to be overlooked, which I think maybe it has been, is that prospectively we're not understanding or maintaining the idea of a uniform notion of expansion because of the illusions of our senses and the observations we make with them. Yep, okay, so that's my theory on the expansion of the universe and the proposed acceleration. Still looking for data that would contradict this, and I'm not going to be upset if I'm wrong. I think that would be okay. I want to see the data. I want to know how and why they've come to these conclusions, because I'm hearing contradictory information about the universe, and what they're hypothesizing isn't making a whole lot of sense. Now, there's the big crunch idea and the big chill, I think is what it is they're calling it. And none of these things are anything that we have to worry about now, or for who knows how many generations. There's a lot of stuff that's going to happen prior to that. On a cosmic scale, it's just ridiculous, the amount of time it's going to take to do that. I mean, even the distance between all the galaxies and super galaxies and clusters is so difficult to imagine, because we view it on our computer screens like this. It's like, okay, we're going to put the whole observable universe on a map on a computer screen, and it really distorts the size of it. And to know that beyond our cosmic horizon it goes on infinitely, and the numbers that we're using in our measurements, we just don't have any type of scalable reference in our daily lives. And this has been said in other places. So, this has been The Engineer. Thank you for listening.